5 points for each problem. So what was the difference between a sequence and a series? We talked about arithmetic sequences and arithmetic series. What was the sequence?
Ratio.
Sequence is just A1, A2, A3, A4. The series, what do? We actually add them up and get a number, get a sum. So that's what we're looking at today with our geometric sequence, though. So here we have our geometric sequence, A1. And again, as we saw before, we're just multiplying by r to get to the next term. So A1r, A1r squared, A1r cubed, all the way up to A1 times r to the n minus 1. Give me that first term, second term, and so forth. So our sum, which we denote by S sub n, in 1 to n, all we did is A1 times r to the negative 1, using our sigma notation. From here we come up with the formula. A1 times A1 times the quantity 1 minus r to the n, all divided by 1 minus r. Another nice formula for you guys to know. That being said, Friday, next week sometimes I'll pass out an index card that you guys can use to write down the formulas. So basically know how to use the formulas, utilize them. I won't require you to memorize all these formulas. So for my finite sum of a geometric sequence, so our series, we come up with that sigma notation gives us that A1 times the quantity 1 minus r to the n divided by 1 minus r. So here we want to find the sum n equals 1 to 7, 2 to the n minus 1. So our S7, A1 times 1 minus r to the, which is 7 over 1 minus r. Do I know what r is here? I'm sorry? Yes, no? How do we know what to do? Right, it's in the formula, right? Our A1 r to the n minus 1. And if we didn't know this, we could also just say, okay, what is the first term? The first term when n equals 1, what do I get? Right? When n equals 2, so I'm going from 2 to 0, so to the first, to the second, to the third. At each time, what am I doing? Multiplying by 2. So I know I'm multiplying by 2. I know that is my common ratio. But again, here it should be obvious to see, as I have the summation of 2 to the n minus 1, that 2 is in fact my r. So coming up with that sum, we already calculated what is A1. 1. When n equals 1, we came up with 1, right? So I have my 1 minus 2 to the 7 over 1 minus 2. I'll do the tough part. There. So 1 minus 2 to the 7th. 2 to the 7th is 14. So 1 minus 128 over negative 1. So it gives us a value of the sum equaling 157. All right. Questions on it? So sometimes we're not just looking at that from 1 to 7. The majority of the times we're looking where the summation has the terms of an infinite geometric sequence, which we call an infinite geometric series. Or the majority of times we don't even say infinite, we just say geometric series. So when we say geometric series versus finite, right, geometric series is where we're counting up from 1 to infinity. We have an infinite amount of terms. So here, if r is less than 1, the infinite geometric series has the sum s, and our sigma notation summation of I equals 0 to infinity of a1 times r to the I. This one becomes a tricky formula here because it equals terrible, isn't it? A1 divided by 1 minus r. The absolute value of r, my common ratio, that absolute value is greater than 1. It doesn't have a sum. So this only works as far as if our r, our common ratio, has an absolute value less than 1. If we take a look when we talked about that finite, our sum from 1 to n, when r is small, when r is 1/2, 1/4, 1/3, whatever have you, and n gets larger and larger and larger, what's going on with this term? When r is small, so 1/2, 1/4, 1/3, and now I'm going to the tenths, to the thousandths, to the millionths. It's getting smaller. It's pretty much going to 0, leaving me behind with 1 over 1 minus r times a1, or the a1 over 1 minus r. That's where this is derived from. I'm not going to touch on that, but it's good to know where everything comes from. So, here we want to find the sum of this geometric series, n equals 0 to infinity, of 5 times 1/2 to the n. Where is my r? 1/2. Not 5 times 1/2, but 1/2, because it's the 1/2 is the only thing that's raised to that power. Right? I'm multiplying 1/2 at each step. So to utilize a formula, right, for our geometric series, I need to know r, and I also need to know a1. So what is a1? So when I let I equal 0, when I let n equal 0, 1/2 to the 0 degree is 1. So I just wind up with that. A1 is equal to 5. So, what's the formula again? So we wind up with 5 over 1 minus 1/2. Five over 1/2, or just, as you already said, come up with our sum equaling. Yes?
Wait, I'm confused how I got the 5.
So here, my very first term, I'm going to do what? I'm going to let n equal 0. So when I let n equal 0, I get 5 times 1/2 to the 0 power. What's anything to the 0 power?
0. 1.
1. Right? Anything to the 0 power is 1. This gives me 5 times 1,
Oh,
which is 5.
okay.
So my very first term is just 5. And you got remember, it's always going to be set up in the form of A1 times R to the n. So that A1 is always going to be the one that doesn't have the power. All right? So in this case, we have 5 plus 0.5 plus 0.05. We want to come up with the sum of this geometric series. Do I know A1? Tough one there. That's the toughest one to find. Right? So how do I find my R though? How so? So you understand, we take our A2 over A1, our A3 over A2, our A4 over A3. So here my 0.5 over 5. 0.5 over 5 is, if you can't readily see this, folks, move your decimal over perhaps. So there you're going to say we get our R, a common ratio equaling 1/10. A1 was 5, that very first term. So our S, again, A1 over 1 minus R, 5 over 1 minus 1/10. When I'm dividing by a fraction, same thing as doing what? Multiplying by their reciprocal. So that's 5 times 10 over 9, or just 50 over 9. Question? All right, so here, a deposit is made of $100 on the first day of each month in a savings account that pays 6% compounded monthly. Find the balance of this annuity after 4 years. So, what's my formula I'm using here? Absolutely. A equals P times quantity 1 plus R over N raised to the NT power. What is my P? The R? N? Since we're doing it monthly. Yeah, we'll go with that. You'll see, I hesitate on that. So, 0.06 divided by 12. I'm doing 12 into 6, not 6 into 12. 12 goes into 60 how many times? So, this is what I would expect for what? What are we doing here in this particular problem? We're saying we're putting $100 in. So it's the first month I go there, I put $100 in. And it's going to accrue interest for how many months? For 48 months. The next month I go in there, I put $100 in. It's going to accrue interest for 47 months. I go in there the following month, put $100 in, and it accrues interest for 46 months. All the way on down to that last month, I put $100 in, and it only accrues interest for that 1 month. So here we can say for our, let's say our A48, representing our 48 months, That gave me that 100, 1.005, 48. For that 47, what is it? Absolutely. Always on down to that last month where we only kept it in the bank for 1 month. 100 to that first degree. So in other words, they're asking us to find the sum for those first 48, right? Our sigma notation, I equals 1 to 48 of our A1, R to the n minus 1. What is my A1? This is my A1. As I already said, 100, right? 100.5. 100 times 1.005, 100.5. Right, that's my A1 times R. What is R? Why? It's a formula, absolutely, and because you can see at each step, right? When I went from A1, A2, A45, A46, A47, A48, at each step we're just multiplying by that R, so we've already said, of 1.005 to the I minus 1. This is what we're trying to find, right? That's my summation notation. Is there a formula for this, or do we want to calculate all of these 48 terms? If you got nothing else to do, calculate all 48 terms. Or else we can use what? A1 times 1 minus R to the n divided by 1 minus R. So my A1 again is 1 minus to the what power? And then we all can do this in our head, right? I know we all came up with this number. $5,436.83. Again, the test on Friday, not tomorrow, but the test on Friday, do not expect using the calculator. That being said, you should be able to do everything above that blue line. Right? Without the use of a calculator.
So,
Ask for it.
so you want us to do what you just...
Well, I didn't say that you are going to. I'm just saying, don't expect to have the use of a calculator, but that being said, don't say, okay, getting this number, it's impossible using a calculator, so I'm going to completely ignore it. I can ask you to set this up or, solve it always down to that blue line, right? That's all I'm saying. All right? Questions? Wrong way. I guess you guys want to play with this stuff, right?